All right, let's see how you guys did on your practice problems. So the first thing we were saying that we were going to check is if x and y are on the same side or if y is by itself. If you'll notice, this y is by itself. So since that y is by itself, we are going to begin with our starting spot at -3. And then we are going to move this from the slope. The slope is going to move that point. So what we're going to have is 2 over 1. So we're going to go up 2 over 1 right there. It gives us the angle of our line, and we can draw it. We're going to go down to the next one. If you'll notice, once again, y is by itself. So we have our starting spot, +2. So we'll start at +2. The slope is going to give us an angle of line from there. So put that over 1. And then we go down 3. 1, 2, 3. +1. Draw that. Oh, whoa, that was a bad drawing. Let's try that one more time. Hey, that was good. Okay, so since we drew that, now we can see that there is an intersection point. If we'll look right there, it's at +1 for the x and -1 for the y. Awesome. Let's try the next problem. If you'll notice, we have x and y on the same side for this one. So if you remember, when we do this, we are going to use the cover-up method because this is a standard form line. So we're going to cover up one of them. We're going to get rid of one altogether, and we're going to solve. Well, y equals 1. There's no solving there. It's just right there, y equals 1. We're going to do the same thing for the x now. We're going to cover up the y, get rid of it, plug a 0 in, essentially what we're doing. And then right now you have 2x equals 1. Well, when we solve for that, you're going to divide both sides by 2. And that is going to be x equals 1/2, or right there. Okay, drawing that line, we should be somewhere like that. Okay, now we're going to erase that, go down to the next one. If you'll notice, there's x and there's y on the same side. So what are we going to do? We're going to take that 2x right there, and we're going to cover it up. And we get -y is equal to 3. Okay, well, we can't have a -y, so we're going to get y is equal to -3. We're going to multiply both sides by -1. If we'll look, that spot's right there. Cover up again. We're going to cover up now the y. We get 2x is equal to 3. This problem I kind of give you a doozy to start with your standard forms to see if you guys kind of remember how to do that. We're going to divide both sides by 2. X is equal to 1.5. 1.5 is right there. So we draw that line. We get an intersection point of, once again, 1, -1. Okay, let's try the next one. Number 3. So we're going to check. Well, if you'll notice, y is by itself there, so we're going to have to start with our starting spot at +1. Down 1. Oh, sorry. We talked about the slope. There's a -1 right there in front of that, and underneath that there's always a 1 as well. So down 1, +1. So we are going to get this line right here. And some people are going to ask, can you keep on doing that, down 1, +1? Sure. If we're taking that slope, down 1, +1, down 1, +1, down 1, +1, down 1, +1. Just like if that's our slope right there, we could actually say, you know what? The negative we're going to put on the bottom. If you did that and you put the negative on the bottom, not a problem. Starting still with our starting spot, it would go +1 and then back 1. So +1, back 1, +1, back 1, +1, back 1, +1, back 1. Same thing. Okay. All right. So now the next line. Okay, this one right here, this is a little more fun of a line. Where is y always equal to 3? Well, we know y equals 3 right here, but that's not a line. If I were to ask you what that point was, you would say it's 0, 3, where y does equal 3. But then I would ask, where else does y equal 3? Could I pick out some random point like over here? And I would get something like 4, 3. That's still y equals 3. In fact, this is 1, 3, 2, 3, 3, 3, 4, 3, 5, 3. Right? So y equals 3 is this horizontal line. So where's the intersection? It's right there at -2, 3. Okay, let's try these ones. we have x and y on the same side, so we're going to use the cover-up method. Get rid of that. We get negative 3y is equal to negative 6. Well, divide both sides by negative 3, y equals 2. Right there. Okay. Now we're going to cover up method again, and it's just x equal to negative 6. There's no solving right there. That's just that. Okay. We go down the bottom one. X and y, once again, x and y on the same side. So with x and y being on the same side, once again, we get to use cover-up method. So let's cover up the first one. You get negative y equals 3. We've had that before. We multiply both sides by a negative 1. We get y equals negative 3. Right there. Once we do that, we're going to use cover-up method right there. We're going to get 2x is equal to 3, and x equals 3 divided by 2, right? Because we're going to divide both sides by 2, and we're going to get 1.5 again. So if you'll notice, this line is the same as that one right there. We see that repeated right there. But since the other line is different, let's mark that one first. X equals 1.5 right there. When we draw that, since the other line is different, we have a completely different intersection point. So that is going to be 3, 3. Okay. Next, we are going to decide, is x and y on the same side, or is it y by itself? You'll notice y is by itself here and here. So both of these, we are going to start with our starting points, and then we'll move with our slopes. So start with positive 2 on the top. We're going to do this one first. Positive 2. That slope is this right here. It cannot be a negative on both. You have to decide. You can put a negative on the top or the bottom, but you must decide. So I'm going to say top, which means I'll go down 1, positive 3 to right there. Now, if you'll notice, what happens if you're like, no, I prefer the negative on the bottom. Okay, put the negative there. It would be positive 1, and then back 3. Still the same line. Same thing either way. There's my line. So now that we have that, I'm going to forget about that top one right there, and we're going to go down to the bottom one. We start at negative 3. We have a slope of negative 2 over 1. So we're going to go down to positive 1. And then once we go down to positive 1, we're able to draw that line. Now here's the hard part. When you're drawing the line, where does it go? Especially if you're not drawing a straight line. So let's continue our slope. This goes up 2, back 1, up 2, back 1, up 2, back 1, up 2, back 1. It makes it to where you don't have to worry about having a perfectly straight line because you know where that intersection is going to be. It is right there. What is that spot? Well, it's negative 3 for the x, positive 3 for the y. Okay, last one. You guys are doing great. If you need to, go back, pause the video, try it again, see how it goes. We see y is on the same side once again. So I have a starting point of positive 3. And then I have this slope idea again where I have to decide positive or negative, or which is the top positive or the bottom positive, and which one's negative. So I'm going to call it top negative, down 1, positive 4. Once we get that, we're going to connect that dot right there. Now we're going to do the bottom one. So with the bottom one, we are going to have y by itself again. So we're going to start at negative 2. And then we need to decide here. We got negative 3 over 2. We need to decide. I'm going to put the negative up top. It's just what I normally do. And then we are going to go down 3, positive 2. And we're going to once again have that issue. Okay, where's that line connect? Well, if I went up 3, back 2. So up 3, back 2, up 3, back 2, up 3, back 2. Right there. So that allows us not to have a perfectly straight line and still get our answer of negative 4 for the x and a positive 4 for the y. Awesome. I hope it went well for you. If not, you can totally meet me at office hours, or you can attempt to maybe try it again, rewind, go through it. Thank you. Have a great time.